Let's do some U-substitution examples. This is a second video. These questions are maybe a little bit more difficult than the questions in video 1 that I have on my channel, so go check out that one. This video also assumes that you know basic integration rules. So let's get into some examples. So for number 1, we said that a strategy for choosing U is a lot of times if you have stuff in parentheses, a lot of times that's going to be your U. And that is your U in the first case, in this case. So I'm going to make U equal to 2y plus 1. Take the derivative, we get du equals 2 dy. So I have 3 dy, but I want 2 dy, so I'm going to put a 2. And like we talked about in the first video, I can't just put a 2 in the middle of my problem. That's going to change my answer. So, but I can put a 2 times 1/2 because 2 times 1/2 equals 1. And so putting a 2 and a 1/2 doesn't change my problem. So if I want to put the 2 with the dy, that's okay, but I need to put a 1/2 out front. From there, let's see, I want to put my 3 out front also. It's not going to help me with my problem. So 1/2 times 3 is 3/2. I'm going to replace everything, make everything in terms of u. So I have 1 over u to the 5th du. To make my integration easier, I'm going to rewrite this as u to the negative 5th du. All right, let's integrate. Negative 5 plus 1 is negative 4, so I'm multiplying by negative 1/4. Don't forget your plus c. I'm going to multiply these fractions out front, negative 3 over 8. Replace your u. We want everything to be in terms of y. 2y plus 1 to the negative 4 plus c. Last step, we don't really want negative exponents in our answer, so I'm going to rewrite this as a fraction. And that is it for this first problem. Next problem, I know how to integrate a radical, but not when there's a 4 plus t in there. So I'm going to make u equal to 4 minus t. I'm going to make u equal to 4 minus t. That means du is going to be negative dt. So I have positive dt right here, or just dt. So I'm going to multiply it by negative 1, which means I also need to put a negative out front because I want to make sure I'm multiplying by 1. From there, we can write everything in terms of u. I have the square root of u du. I'm going to rewrite it one more time, u to the 1/2 du. Let's integrate. 1/2 plus 1 is 3/2. Flip that, and we get 2/3 plus c. Rewrite everything to be in terms of t. And that gives us our answer. Let's do another one. So here I have natural log inside parentheses. So it's inside parentheses, so that's a good clue. We also don't know how to integrate natural log unless you know integration by parts. So natural log is a good thing to make u equal to. Du, so derivative of natural log is 1 over x, and we're going to have our dx. Now I want you to notice if I rewrite our problem, I have my natural log of x squared, and then I have an x in a denominator. So that's the same thing as 1 over x, and I have my dx. So I have my full du in my problem already. So I can rewrite everything to be in terms of u. I have u squared du. So let's integrate. And then rewrite everything to be in terms of x again. So I'm going to substitute that natural log of x back in there. And that is it for this problem. Let's do another one. Okay, number 4, I have stuff under a radical, so same thing, we probably want to make that our u. 1 plus e to the x. Let's see, derivative of 1 is 0. Derivative of e to the x is e to the x. So I'm going to have e to the x dx. Notice e to the x dx is already in my problem, so I have du in my problem. So this is the square root of u du. I'm going to rewrite it one more time, u to the 1/2 du. We're ready to integrate. 1/2 plus 1 is 3/2. Flip it. Don't forget your plus c. Rewrite your u back in there. 1 plus e to the x to the 3/2 plus c. Okay, couple more examples. Number 5, I have stuff under a radical, so let's make that our u. Take the derivative, du is 3z squared dz. Notice we have z squared dz, but I want 3z squared, so I need a 1/3 out front. We can write this to be in terms of u. I have my 1/3, and I'm going to say 1 over the cube root of u du. From here, I'm going to rewrite it one more time. This is the same thing as u to the negative 1/3 du. Let's integrate. Negative 1/3 plus 3/3 is 2/3. Flip that, we get 3/2. Don't forget your plus c. Simplify the fractions, the 3's cancel. I'm left with 1/2 u to the 2/3 plus c. Rewrite everything to be in terms of z. So I have that 1 plus z cubed plugged back in. And that is our final answer. One more problem, just like we talked about before, unless we know integration by parts, we don't know how to integrate natural log of x yet. So that's always a good strategy. I also want you to notice when we take the derivative of natural log, we get 1 over x dx, and that's already in our problem. So we can think ahead, or we can try something, and if it doesn't work, we can try something else. But this does work, so let's split it up. I have my 1 over natural log of x. I'm going to move my 1 over x over just to kind of show you. So this whole part is going to be my du, and then I'm going to have 1 over u. So let's rewrite it. Okay, let's integrate. Keep in mind that the integral of 1 over u is the natural log of the absolute value of u. And we don't want it to be in terms of u, we want it to be in terms of x. So I have the natural log of x plus c. So it looks kind of funny, but that is our answer.